Hello students, welcome to Sri Jendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 5 of a unit semiconductors. So let's begin with today's class. In today's class we are going to discuss about the optoelectronic junction devices. So let's begin with today's class. In optoelectric junction devices, first we are going to discuss about the solar cells. As you have seen the solar cells at various places, now even government is promoting to use the solar cells because we are living in a country where we are having the solar energy almost 12 months in a year, and so that it is the essential part to convert or to use the solar energy. So we are using the solar cell. As you can see this, it is a PN junction device which can convert solar energy into an electrical energy. And as you can see the different layers of the semiconductor, this is n-type semiconductor, and as a thin yellow line has been seen, that is the PN junction over here. And as you can see this, it can create the potential difference across these two terminals can create a potential for us, and that potential is the proof of conversion of light energy, we mean solar energy, to the electrical energy. As you can see this is a sandwich kind of layers it has been developed, and on this sandwich kind of layer a sunlight has been fallen. Then due to certain processes that we will see in detail, that due to this processes it can convert this sunlight to the electrical energy. Let's have a look. This solar energy, the solar cells, is containing silicon or gallium arsenide PN junction diodes, in which the lower layer is of p-type silicon semiconductor of thickness about 300 micrometer, and over that the thin layer about zero point 0.3 micrometer of entire silicon semiconductor is grown by the diffusion process. Now the p-type layer, this p-type layer is coated with a metal, and on top of the surface of n-type a very thin metallic grid is deposited, and this thin metallic grid acts as a front contact. So when light with energy, which is equals to HF, which is greater than the energy gap, which we call as an E greater than EG, incident between the gaps of the grid on top of the surfaces, then electrons and holes pairs are created, and this electron and holes pair creation at the junction due to absorption of photons. So due to this absorption of photons, EMF can be developed, and this basically the DMF is being developed in three different processes. One of them is the generation, another is the separation, and the third one is the collection. Now let's understand one by one what the generation is. The generation of electron and hole pairs due to incident light which is close to the junction. Separation, it's an electrons and holes due to electric field of the depletion rear. So electrons are swept to n site and holes has been swept to p sites. So the electrons reaching the n site, are collected by the front contact, and the holes that are reaching to the p sites are collected by the back contacts. So p side, as you can see this, p side becomes positive and n side becomes negative, so that photo EMF is generated, and this photo EMF can produce a photocurrent in the circuit. So if we plot the voltage versus current, voltage on the x-axis and current on the y-axis, if we plot the voltage versus current characteristic for the solar cell, then this is probably alone material or alone element whose VI characteristics lie in the fourth quadrant. Always remember this. other than the solar cell, none of the element is having their characteristics in the fourth quadrant. Yes, so as you can see, this is the open circuit voltage and this is the short circuit current. Even please do remember this, that this voltage is of open circuit voltage and current is of short circuit current. One time by J and one time by Neet, that means AIPMT, they have asked about the characteristics of the solar cell. So because, and as we understand that solar cell is drawn in the fourth quadrant because solar cell does not draw current, but it supplies the same current to the load. Yes, so it is not using it, but it is going to supply it. Now let's look at the uses, applications of the solar cells. It has been used for charging storage batteries in daytime, and it supplies a current. It supplies a current in the night time. That can be used in artificial satellites, as in the artificial satellites as a power they are using only the solar cells. As you have maybe you have seen this kind of wings have been there, and this wings is keep on rotating through around its blades, so that they can absorb maximum amount of heat energy from the solar cell, and they can produce a maximum amount of current for us, and they can feed it to the artificial satellites. Used in the solar calculators, used in the solar cookers, even solar water heaters are available. Solar water heater are available. Even certain governments provide various schemes so that people in our country start using the solar energy. Even certain governments have released that you should attach, or I should say you should at your home or at your terrace, let's say, you are going to install a smaller solar panel which can generate a power, which can generate an energy, and that energy will be taken, that means the purchase by the Indian governments. So various schemes are going on, and because we can take and benefit of this, because we are living in a country where solar energies are available almost 12 months in a year, every time, each day. So let's have a look at certain quick questions. Solar cells. Solar cells are used for charging storage battery for the supply of current. Yes. Solar calculators. Absolutely right. Artificial satellites. Correct. And all of the above. Yes. Great. So solar cells are used for everything. Next. Optoelectric junction devices converts solar energy into, yes, electrical energy. So it is going to convert solar energy into electrical energy. So this was all about the solar energy. Now let's look at the different device. The second optoelectronic device, this is the photodiode. Let's have a look what photodiode is. A photodiode is a special type of PN junction diode fabricated with a transparent window to allow a light to fall on the diode. Even its symbol is something like this, that this is normal PN junction diode, and on this light is going to came from the outside. That means it is having symbol like this, that from the outside world light is coming to this diodes. This is PN junction diode, and it is operated under reverse bias condition. This is another very important characteristic of this photodiode, because mostly the diode works in the forward bias. This is the diode which works efficiently in the reverse bias. This is the V versus I characteristics of a photodiode. For different illumination intensity, that we have changed the intensities I1, I2, I3 and I4, and due to each different intensities, the photocurrent that has been passed through the diode is the different one. So let's check first how does it work. Let's have a look. So when light of frequency greater than the forbidden energy cap is incident on a photodiode, Additional electron and hole pairs are created in the depletion layer or near the junction, and discharge carriers will be separated by the junction field before they are going to recombine. So then the electrons are collected on the n sides and holes are collected on the p side. As a result, a reverse current flows through the load resistance RL, and the magnitude of this reverse saturated photocurrent depends on the intensity of incident light. So this diode is used in reverse bias because the reverse saturation current can be measured very easily, and which is directly proportional to the intensity of incident light. A dark current, when no light is incident on the photodiode, a small current do exist in the circuit in reverse bias. That is what we call as the dark current. I hope this is clear. Is it? Great. Let's look at the uses of the photodiodes. It is used as a photodetector to detect the optical signals. It is used in switching the light on and off. It is used in computers, in punching cards, etc. It is used in many optical communication equipment. So it is having very wide range of applications where we are using the photodiodes. Next, let's look at the certain quick questions. A photodiode is operated under forward bias? No. Reverse bias? Yes. So photodiode is operated under the reverse bias condition. Next question. When no light is incident on the photodiode, a small current exists in the circuit in reverse bias. That is what we call as the dark current. Yes, this is the correct option. I hope this is clear. So this is all about the photodiode, and now let's look at the next optoelectric device, which we call as an LED, which is it's a light emitting diode. It's an LED. Let's have a look. First, LED or light emitting diode, definition of it is a heavily doped PN junction diode which emits spontaneous radiation under the condition of forward bias. That means it converts electrical energy into the light energy. So basically we are going to provide it an electrical energy, and with the help of this electrical energy it will convert this energy into the light energy. And if we look at the symbol of this, it is something like this, that light has been moving out from this diode. So that's why it is called light emitting. Light has been emitted from its surface. It is LED. As you can see this, that if you go to the market and ask for the LEDs, they will provide you something like this, that this is the body, where you are going to have, this is the actually light from which we are working for, and it is having a two leads. One is the anode lead, another one is the cathode lead, and always it is the case that cathode lead is always the shorter lead, and this is the cathode anode lead. Yes, this is the one different version of the LOD, and you can see this also in the market. Now let's look at the certain detailed view, that this is a sandwich regions has been shown, and as you can see this, the top of there is the P type, and there is an active region, and then it would be an N type, and there is a different substances. As you can see this is the symbol of the LEDs, that light is coming out from its circuit, and this is the practical approach to see the LED, that long one of the lead would be a longer one, another one would be the shorter one. I hope this is clear. Let's see the working of the LED. We say that when diode is forward biased, electrons will move from n type to n side to p side, and holes will move from p side to n side through the junction. And as a result a concentration of minority carriers increases very rapidly at the junction boundary, and as compared to the equilibrium concentration when there is no bias across the junction. Therefore, there are excess minority carriers on either side of the junction, which will recombine with majority carriers near the junction. And due to this recombination, the energy is released in the form of the photons and in the form of the heat. So when if of the diode is very small, the intensity of light emitted is also small. For PN junction diode made up of germanium or silicon, the larger 1% of energy, that is what it release, converts into the heat. So now what we are doing is that PN junction diode made up of materials like gallium arsenide or gallium phosphide and something like that, the larger 1% of energy released, that will converted into the visible light. So when they are going to dissipate their heats in a form of a light, that is what our requirement is. So hence this are used as a light emitting diode, or we can say light source. Now the color of light that is emitted by the LEDs depend upon the type of material that we used in the making of the diodes. Examples such as the gallium arsenide would be there, then it would be an IR radiations would be there. Gallium phosphide, it's a red or green light. It's in gallium arsenide phosphide, it would be a generally red or the yellow light. So different type of material is capable of providing a different kind of light, and that is what our requirement is. Now let's discuss the various locations where LEDs are used. Where does LEDs used? They are used in the burglar alarm systems. So in burglar alarms, IR LEDs are used. They are used in calculators. They are used in digital watches for numerical displays. They are used in the computers, in optical mouses. They are used in the traffic lights. They are used in remote controls. This all are the list. This is the list which has been mentioned by the NCRT and all that. Now you tell me which is the place where LED is not going to be used. Yes, so it is very difficult question, because nowadays if you go anywhere, if you see any electronic device, you just pick any of the device and you will not find almost any device which does not contain LEDs. At least a single LED will be attached, a single LED will be fabricated if your device is required to light up. Yes, so LEDs are the most common optical instrument, or I should say it's a most common optoelectric junction devices which is being used almost every place, almost every time we are using and we are dealing with the LEDs. Our traffic lights having multiple LEDs, our television sets having large array of the LEDs, our laptops, it is having LEDs too. Yes, because as you can see that there is a certain lights are there in the laptops, in the behind the keyboards. Yes, how that light has been used. Yes, they have been developed using the LEDs. Why they are most popular, why LEDs are most popular? First reason is it is very less expensive. If you go to the market, you will get the LEDs in just 3 rupees each LED. Second, the most important is it can be operated at very low voltage. That means if let's say if I want to use as a backlight of my laptop keys, I can prefer the LED because it is not going to consume much power from my battery of the laptops, and that is the requirement. Because if this LEDs will have, or if this LEDs will consume more power, then what processor will be working on? I hope you understand this. So LEDs are the most common optoelectric junction devices that we used. Generally, LEDs do not emit light in reverse bias. So it is working in forward bias only. And voltage versus current graph of LED is similar to that the SI junction diode. Yes, the normal PN junction diode and the VI characteristics of the LEDs are almost similar, no difference. Let's have a look certain quick questions. Generally, LEDs do not emit in, yes, they are not going to emit the radiations in the reverse bias. Next, LED is a heavily doped PN junction diode which emits spontaneous radiation under the forward bias, and it does not emit anything in the reverse bias. I hope this is clear. Is it? Great. So let's wind up this session over here. This was all about the optoelectric junction devices, as it's a very small lecture, almost 21-22 minutes. But this contains a very vital information. This can work for you for your board examinations too, as well as for your examination of Neet or J. So please revise it. I request you guys to please go through the NCRT books also for this kind of topics, because a large amount of information is being contained by the NCRT, which may be left something, maybe knowingly or unknowingly. Yes, so it is quite possible that certain information or certain data has been missed out in this session. So please go and revise this session through an NCRT textbook as well. Thank you. Have a good day. Take care. Bye bye.